In this video, I will teach you how to do basic trig integration. If you appreciate the content, please give it a like. Because we memorized the derivatives of all 6 trig functions back in first semester, we also know these 6 trig integrals. For example, to evaluate the integral of cosine x, you ask yourself the derivative of what is cosine x. Since we know the derivative of sine x is cosine x, then sine x is the antiderivative of cosine. Don't forget to add the plus c, the constant of integration. To evaluate the integral of secant squared x, you ask yourself the derivative of what is secant squared. Since the derivative of tangent is secant squared, tangent x is the antiderivative. Again, plus c. To evaluate the antiderivative of secant x tangent x, you ask yourself the derivative of what is secant x tangent x. Since the derivative of secant x is secant x tangent x, then secant x plus c is the antiderivative. Similarly, the derivative of what will give you sine x. We know the derivative of cosine is negative sine x, so the derivative of negative cosine x will give you positive sine x. The derivative of what will give you cosecant squared x. The derivative of cotangent x will give you negative cosecant squared x, so the derivative of negative cotangent will give you positive cosecant squared x. And finally, the derivative of what will give us cosecant x cotangent x. Since the derivative of cosecant x is negative cosecant x cotangent x, then the derivative of negative cosecant x will give us positive cosecant x cotangent x. Right now, these 6 trig integrals are the only ones we know. So when you see that you are about to take an integral and there's a trig term in it, the trig term either has to be one of these, or you have to be able to rewrite it as one of these. The trig term in number 1 is sine x, which we know. So the antiderivative of 1 is x. The derivative of x is 1. The derivative of what is sine x? Well, the derivative of cosine x is negative sine x, so the derivative of negative cosine x will be positive sine x. And don't forget the plus c. Be so careful right now. On number 1, the dx means we were integrating with respect to x. That's why the antiderivative of 1 was x. But on number 2, we see a d theta. So we are integrating with respect to theta. Therefore, the integral of 1 will be theta, not x. A common mistake is to put an x here instead of the theta that we actually need. Now, the derivative of what is cosine? The derivative of sine theta is cosine theta, so that's the antiderivative. Just don't forget the plus c. Secant squared is on the list, so we are good to go. Notice we are integrating with respect to y. So the antiderivative of 2 will be 2y. The derivative of what is secant squared? The derivative of tangent is secant squared. So tangent y plus c. Cosecant squared is on the list, so we can jump right in. We are integrating with respect to u. So the antiderivative of 2 will be 2u. The derivative of what is cosecant squared? The derivative of cotangent is negative cosecant squared. So the derivative of negative cotangent will be positive cosecant squared. Don't forget the plus c. Secant x tangent x is still on the list. We are integrating with respect to x, so the antiderivative of 1 is x. The derivative of what is secant x tangent x? The derivative of secant x is secant x tangent x. Just add the plus c. Watch out, you guys. Starting with number 6, we are getting into some trig expressions that are not on the list. So we need to rewrite them so that they are on the list. If you ignore the extra sine theta in the denominator, you might notice that we have cosine theta over sine theta. That's cotangent theta, which we have right here. So this is the one I'm sort of shooting for. Because of the 2 sine thetas in the denominator, you can separate this fraction into 2 fractions, 1 over sine theta times cosine theta over sine theta. But 1 over sine theta is cosecant theta, and cosine theta over sine theta is cotangent theta. So we've turned an expression that was not on the list into an expression that is on the list. So now we can integrate. Remember, we are integrating with respect to theta. So the antiderivative of 1 is theta, not x. The derivative of what will give us cosecant theta times cotangent theta. We know the derivative of cosecant theta is negative cosecant theta cotangent theta. So the derivative of negative cosecant theta will be positive cosecant theta cotangent theta. So that is the antiderivative. Don't forget the plus c. Looking at number 7, this trig expression is not on the list. So we need to rewrite it so that each term is a trig expression that is on the list. Let's try doing the distributive property and see what happens. Secant y times secant y is secant squared y, which is on the list. And secant y times tangent y is secant y tangent y. That is also on the list. So we can integrate. The derivative of what is secant squared. The derivative of tangent is secant squared. So the antiderivative is tangent y. The derivative of what is secant tangent. The derivative of secant is secant tangent. So that's the antiderivative. Just don't forget the plus c. Pause the video and try to do number 8 on your own. This trig expression is not on the list, so we need to rewrite. When in doubt, try rewriting everything in terms of sine and cosine. Secant squared u is 1 over cosine squared u. Multiplying these two together, you get sine squared u over cosine squared u. But this is tangent squared u. Unfortunately, tangent squared u is still not on the list. Does anyone remember a way we can rewrite this expression as something that is on the list? Back in AP Pre-Calculus, we learned about Pythagorean identities, the most important of which was sine squared u plus cosine squared u is equal to 1. Dividing each term by cosine squared u gives us a second Pythagorean identity. Sine squared u over cosine squared u is tangent squared u. Cosine squared u divided by cosine squared u is 1. And 1 over cosine squared u is secant squared u. Aha! 1 plus tangent squared u is equal to secant squared u. And secant squared u is on the list. However, before we do that, let me complete my little side lesson and remind you of a third Pythagorean identity. Let's divide each term by sine squared u. Sine squared u over sine squared u is 1. Cosine squared u over sine squared u is cotangent squared u. And 1 over sine squared u is cosecant squared u. So be sure you know all 3 of your Pythagorean identities. They are going to come up in AP Calculus. Back to this. The derivative of what is secant squared? The derivative of tangent is secant squared. So tangent u plus c is the antiderivative. Pause the video and try to do number 9 by yourself. When in doubt, try rewriting everything in terms of sine and cosine. Tangent squared is sine squared over cosine squared, and cosecant squared is 1 over sine squared. But now we notice that we have sine squared in the numerator and the denominator, so these will cancel out. That leaves behind 1 over cosine squared theta, but 1 over cosine squared is secant squared. Uh-oh, I accidentally put theta right here. It should be an x. Anyways, secant squared is on the list, so we can go ahead and integrate. We are integrating with respect to x, so the antiderivative of 1 is x. The derivative of what is secant squared? The derivative of tangent is secant squared. So, tangent x plus c. Pause the video and try number 10 on your own. I'm noticing that sine over cosine is tangent, so I'm betting that it's going to be this one that we can turn the expression into. Let's pull one of the cosines off to the side as 1 over cosine theta, and then that will leave sine theta over cosine theta. In other words, secant theta, tangent theta, which is on the list. The antiderivative of 1 is not x, it is theta in this case, because we are integrating with respect to theta. The derivative of what is secant tangent? The derivative of secant is secant tangent, so theta plus secant theta plus c. Last chance to do one by yourself, so pause the video and give it a shot. Here's a hint. What can we do with this? Well, I just reminded you in the side lesson that sine squared plus cosine squared is equal to 1. So let's make that substitution. How about now, Benson? Cotangent squared is still not on the list. But back to the side lesson, this is one of our Pythagorean identities. 1 plus cotangent squared is cosecant squared. So we can rewrite as the integral of cosecant squared y dy. And cosecant squared is on the list. The derivative of what is cosecant squared? The derivative of cotangent is negative cosecant squared. So the derivative of negative cotangent will be positive cosecant squared. So the antiderivative is negative cotangent y plus c. By the way, these plus c's are very important. On the AP exam, if you don't put the plus c, it's just wrong. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.